Example 5.1.3, calculating the mean and standard deviation for a discrete probability distribution. So we are given the same chart of household size from the U.S. Census of 2010. So our random variable here is still the number of people in a household. And again, if we want to be specific here, we could put in the U.S. in 2010. All right, so the custom calculator, like our binomial calculator, also gives us a discrete distribution here where it's using kind of these little sticks instead of the full rectangles. Again, if we actually wanted to make a histogram out of this, we would basically put a bar the height of the stick, where the stick is in the center of each of those bars. Okay, so that gives us our distribution that we saw earlier. So using the correct notation here, so we've got here is our mean and here is our standard deviation. And probability distributions have parameters. So we would write here that mu sub x is equal to 2.525. And in this case, we were counting people in the household. And sigma sub x, if we round that, is about 1.422. And its units are also in people. So if we were to interpret what this means that we expect a household in the U.S. to have 2.525 people on average. With a standard deviation of 1.422 people. Now, if we were to use the calculator, because again, that's what you'll have available for all of the exams and for the departmental final, we would push stat 1 to get into the lists. Again, we put the values of x here in list 1, their corresponding probabilities in L2. Okay, and again, it's very important that an x and its corresponding probabilities stay across from each other. So like if you forgot one of the probabilities, you can't just throw it in at the bottom of the list. Then we push stat 1 to open one variable stats. Again, depending on what your screen would look like here, we would enter L1 and L2. And when we push enter, our output is here. Now, the calculator is a bit irritating here when we're looking at probability distributions. So as you notice here, next to S, there's nothing displayed for a sample standard deviation because it recognizes its probability distribution when that second column summed to 1. So it only displays a value for sigma x because probability distributions have parameters. Okay, unfortunately, this symbol here did not change to mu. Okay, so it says x bar, but really in this case, since it's a probability distribution, okay, we're going to enter. Again, this correct symbol here is mu, is 2.525. Okay, we have the same problem if we were to give it population data. The calculator kind of always assumes we have sample data. And so again, it never displays a value of mu here. So again, if we're dealing with population data or probability distributions, we're going to take the value that's next to the symbol x bar, but we're not going to use the symbol x bar. We're going to use the symbol mu sub x. So again, we got the same values that we got using StatCrunch. So again, this means that we expect a household in the U.S. to have an average of 2.525 people in it with a standard deviation of 1.422 people.